Hey, good morning, 7th graders. It's me, Mr. Stark, and today I'd like to talk to you a little bit about incomplete dominance. Incomplete dominance is it's a little bit different than regular Mendelian genetics. Regular Mendelian genetics, you're dealing with a dominant and a recessive trait. The dominant masks over the recessive, and the recessive doesn't necessarily go away, but sometimes it will get covered up and then it will reappear a little while later. So with incomplete dominance, we have more than we have. This is kind of like with your blood types and things of that nature, where we have more than one dominant option, and sometimes we have two dominant options that are showing through and trying to assert themselves, and they don't really want to give up what their dominance to be masked over, or they don't want to be recessive. They still want to be dominant. So one example would be with flowers. If you had a white flower and a red flower, they are both dominant colors, and they would then not give up their dominance, but then would kind of meet in the middle or blend together and do what's called incomplete dominance. So a red flower and a white flower will make a pink flower. So today we're going to look at some bikini bottom genetics with incomplete dominance. And so here we have SpongeBob loves growing flowers with his pal Sandy. Her favorite flowers are pumpkins. They're found in red and blue and purple. Use the information and provided your knowledge of incomplete dominance to complete each. Write the correct genotype for each color if R represents red and B represents blue. So again, we have to have two alleles, two letters representing red. They're both dominant, so it'll look like this: big R, big R. And blue will be big B, big B. And then purple is going to be the intermediate or the incomplete dominance version of the red and blue mixing together. And so they would be RB. Okay, so the question becomes, knowing that, what would happen if SpongeBob crossed a pumpkin of red flowers with a pumpkin of blue flowers? So we would take the red and put it on the top of the Punnett square, and the blue on the side of the Punnett square, and then we would fill it in, which we'd get a incomplete dominant, a big R, a big B, a big R, big B, big R, B, R in each one. So give the genotypes and the phenotypes of the offspring. So the genotypes of the offspring are going to be, that's the letters, big B, big R. Okay? And then the phenotype, what is that going to look like? That's going to be purple. Next part is how many plants would have red flowers. Okay, red would be big R, big R. And if you look at the Punnett square, there are no big R, big R. So that red flowers is going to be 0. How many would have purple flowers? There are 4 with big B, big R, which is purple. So it would be 100% purple. And then blue flowers would be big B, and there are none of those in the offspring either, so that would be 0%. Okay? Okay, we're going to continue on with number 3, and then after that I will turn you loose. So to do number 3, I'm going to clear my ink, get that out of there, move it up to number 3 so you can see it. What would happen if SpongeBob crossed 2 pumpkins of purple flowers? Okay, so purple would be big B, big R. There's 2 of them, big B, big R. Fill in the Punnett square, where you get big B, big B, big B, big R, big B, big R, and R, R. Okay, so then we go back to part A. What are the genotypes and phenotypes? So we have a big B and a big B, and that's going to be blue. We have a big R and a big R, and that's going to be red. And then we have big B, big R, and that's going to be purple. Part B, we have how many plants would have red flowers? Well, we have red flowers are big R and big R. And so what percentage of that would be? That would be 25%. Okay? How many plants would have purple flowers? There is 2 of 4, so that would be 50%. And then the last one would be how many plants would have blue flowers? That's big B, and that would be 1 of 4. Again, that's 25%. You add this up, 25 and 50, and 25 is 100%. So we've got all the flowers accounted for. Okay, so we're going to switch over and do number 4 together, and then after that, I'm going to turn you loose. Clear the ink, move it up, and number 4. What would happen if SpongeBob crossed a pumpkin with purple flowers with one of blue flowers? So set that up. Purple is big B, big R, and blue is big B, big B. So we would get big B, big B, big B, big B, big R, big B, big R, big B, big R. Okay, give the genotypes. That would be big B, and that would be blue. And then we have big R, big B, big R, and that would be purple. If SpongeBob planted 100 seeds from this cross, how many would he expect to have of each color? If he planted 100, he got 2 of the 4 are purple and 2 of the 4 are red. So he would say 50 would be purple and 50 would be blue, sorry. And how many red flowers? Big R, 0. Okay, so what I would like you to do is just looking at that, continue on and flip your paper over and work on numbers 5 through 8, which is backwards and upside down here. But work on 5 through 8 and then turn it in on Google Classroom or send me a picture of it. Okay, thanks. Have a great day. Bye.